Okay, example 13 of your chapter 3. Okay, this is a little bit difficult, okay, because there's a new theory or new concept for you to accept. So let me run through the simple stuff first. Z is actually a complex number fitting this criteria. Your job now is with the aid of an Argand diagram, show that the greatest value of argument z plus 2 is pi over 6. Okay, so down here, do not be confused. Okay, do not be confused. You are supposed to draw what thing? You're supposed to draw this. This is the locus that you're expected to draw. Thereafter, give me the result of this. Okay, so the locus here is actually a circle, center at origin, with a radius of 1. Okay, so let me run through first. Okay, what you have down here is actually a circle. Okay, you expect to draw a circle, center at origin, radius of 1. Okay, so from here you must tell me where are your possible z value. Z value, based on your concept of locus, will be any point that is on the circle. Okay, so from this understanding, you need to tell me what is the greatest value of argument z plus 2. So this, very importantly, we're going back to the theory. What do I mean by physical meaning? Or what does it mean in English when we say argument of z plus 2? So it means the angle that the complex number 2 makes, the angle of complex number z as measured from minus 2. I say again, okay, if you go back to your early part of the lecture notes, this will mean I want to find the angle that the complex number z makes with the positive real axis if I measure it from minus 2. So you may not be able to get what I'm trying to say here, but look at it physically now, diagrammatically. Okay, as measured from the point minus 2. Give me the possible values of the argument of z. Okay, as measured from minus 2. So understanding, z can be anywhere on the circle. So if z is down here, this is my argument. If z is down here, this is my argument of z plus 2. If z is down here, this is my argument of z plus 2. Okay, so I repeat again, argument of z plus 2 basically means the distance, okay, or rather the argument, the angle that your complex number z makes with a positive real axis as measured from the point minus 2. So from here, where is the largest possible value? Okay, the largest possible value requires a little bit of geometry. It will happen when this line sort of just touches this point. This will be the largest possible value. Make sense? This will be the largest possible angle that we want. So you need to activate a little bit of trigo, a little bit of geometry from your secondary school. It's a radius and tangent relationship. So if it just touches the circle, if my red line, my red line down here just skim through the circle, it is a tangent to the circle. And if it's a tangent, this will be a 90 degree that it makes with the radius of the circle. So if this is 1, this is theta that I'm trying to find. And this point A is minus 2. What I know is, I know this distance, I know this distance, I know that this is 90 degree. I can make use of my trigo to find this angle. Okay, and that will give me my largest possible value. Similarly, what is the smallest possible? The smallest possible is actually from here. Okay, because it's a negative angle, negative argument. So same thing, these two are symmetrical. This theta is actually equals to this theta. So if I can find the biggest angle, I can find theta using geometry, I can get the other angle to be negative pi over 6 as well.